Hello everyone, today I'll show you how to use a random forest explainability toolkit using Jupyter Notebook. So the first step is to install Jupyter Notebook, and for that we can go to this link and go through the steps to install Jupyter Notebook in the respective machines. So if it's a Mac OS if it's a Mac operating system, then we can just use this link, and if it's a Windows, then we can just go to this link and Linux and so on. So it's very straightforward. We just need to install the Anaconda, and it will install Python and everything together. Don't have to install anything separately, and we can just go through the steps and everything will be installed. So after installing Anaconda, we need to start it. So we'll go to terminal and then type Anaconda Navigator. So installing after installing Anaconda, after the starting Anaconda Navigator, we can create environments for different projects. Just going to the environment tab and then clicking on create will create an environment for each project. I have created an environment RFX, and in this environment we can install the packages that are required for each different project. So here one of the most important packages are rpy2, ggplot, and random forest. So rpy2 is the interface between R and Python, since I have used both R and Python in my in this toolkit. So using rpy2, installing rpy2, we can do that. By installing rpy2, we can use both R and Python together. So the next step is to launch the Jupyter Notebook. So we just go to the home tab and then click on launch. So here we have launched the Jupyter Notebook, and I have already created a new notebook, and so I'll scroll down and open that notebook. So this is the notebook. So to actually run the notebook, we just have to click on each cell, because each notebook is composed of different cells, of a number of cells. We just need to click on each cell and then either click on run or do a shift enter at the same time. Just press shift and enter on your keyboard at the same time. So here we go on like executing each cell, and this is the toolkit of explaining, like, of applying random forest explainability on synthetic data, and more information can be found in this link. If we click on this link, we get all the information about how RFX has been applied to the synthetic data and the results that we have discussed. And then the next step is to enter the data. So here all these are documentation which we can go through, and then to understand what the toolkit is. And also I have given text on how to install, and also attach the link as well. So this particular command actually loads R and Python together, and it's very important to use this command, else we won't be able to use R and Python together. So the next step is to input the training data, and this is the code for the training data. And the training data should actually follow the same format as given in this data, as in, like, the features should be in the left hand side, and the target should always be in the right hand side of the right hand side of the table, else this toolkit will not work. So next step is to input the data. So we need to, like, provide the entire path in order to input the data. So So here we have provide the entire path to input the data, and the data should be in a CSV format, else it won't work as well. So the next step is to perform a grid search, and here we can enter the grid search parameters 2, 3, 4, 5. The next step is to enter entry also we can enter 100, 500, and 1000. The next step is to enter cutoff, so the cutoff will be 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9, and that's it. And the next step is to train the random forest classifier using all the grid search parameter. This training will take some time. So the training is done, and here we have the optimal parameters. We have recorded the optimal parameters and the F1 score and the precision and recall. So the next step is to find the top 10 features using the trained classifier. So we can choose the number of top 10 features we want to see. So here we want to see the 10 most top 10 features in decreasing order of the MDA scores. And then we calculate the MDA score. And here we have all the MDA scores of the top 10 features. So the next step is to provide trade-off between accuracy and the total number of top rank features used. Also, we can see in this case also the among the top rank features, how many features we want to see. Here also I'll choose 10 for simplicity. And this code, this this code calculates the F1 score of each feature at a time, like the top two features, the top three features, and so on. And then we can compare what's the F1 score of the top two features versus all the features, and we can see that just by using the top two features we get the same F1 score. So here this is plotting the F1 score of the two features versus the 10 features. So the next step is to apply Mann-Whitney-Wilcox test, and here it's a straightforward application of the Wilcox dot test function of R, and we can see that the results here. And the next step is to provide the standard deviation. We just need to press click enter, shift enter, and then we just get the standard deviation and the mean of all the features. um, the next step is to identify the important clicks. So here we can either choose a click of 2 or 3, so I'll choose the click of 2, and then enter the grid search again in this case, because the M3 will change, M3 the cutoff and the entry will change, because click of 2 means only 2 features at a time or 3 features at a time. So I'll enter the cutoff, and the M3, so 1 and 2, and the entry also, sorry, 200 for now. And then we will calculate the clicks using the above entered values. Here we have calculated the click, and we can see that we get a summary of what is the best click and which feature with which feature we get the best click, and F1 and F2 are the best most important features, and it summarizes everything. So the next step is to get a one-page summary table, and the one-page summary table, so we can get it in several ways depending on what the user wants. Either we can write it to a to a CSV file, or we can just display it in this Jupyter Notebook toolkit as well, or we can just show it in a tabular format. So I have chosen to write it in in a CSV file, as well as show it here in this in Jupyter Notebook as well. So we just need to do press a click enter, a shift enter, and here we have the MDA values and all the summary, as well as we also have a table. So we can see the table. We have description about each column, as well as the column name and the values for each column and the best feature click. So this gives us the summary table, which can be exported to a CSV file as well. So as we can see here, we don't have to code a lot, and we can just go through the pipeline through the Jupyter Notebook tool. Jupyter Notebook is itself. We just need to run each cell and do a click enter, and just like for each grid search, we can just enter the parameters or the total number of the important features we want to see using some kind of interactive button. So this is the toolkit that I have made, uh, and this is a beta version, and it can be polished more based on the feedbacks we gather from different people. Thank you.